So multi insertion. Earlier we used single insertion. One insertion for female, another insertion for male. But instead of that, we can write a single query. This can create two separate partitions and creates loads data into corresponding partitions. So from EMP, main table, it may be main table. So assume EMP. From EMP, insert overwrite a table. What is our table name? E part, right? E part, and gen equal to female. Select star from, observe the query. Select star where gender equal to F. So this part from column takes from here. And insert override table E part, partition gen equal to male. So in a single query we can execute, we can insert multiple partition columns data, multiple partitions data. Previously we execute same query 2 times. This time we are executing single query to insert data. For creation of a partition table, we use this syntax, right? Create table, columns list, partitioned by, and partition column name we mentioned. So while insertion, what is the column you mentioned? Gen equal to that value. It will create subdirectory in main directory. Okay, let's see the difference. You may not see huge difference here because we have how many records? Max 5 to 7, right? Or 10 records are presented in our EMP table. So select star from EMP where gender equal to female. Observe how much time it will take. It is taken less than a second, right? Less than a second. If you observe same thing, E part, and see the difference. Partition column name, we have to use partition column name. It is taken more than actual table, right? Just now we discussed partition takes less time than actual, but it is taken more time. Non-partitioned given 125 milliseconds, but partitioned given 482 milliseconds. Partition is taken more time. So this is small data. So we cannot expect big differences with, if you run same thing once again, it is taken very less. If you run previous one, EMP, see the difference. E part, again I am running E part. So little slight difference compared to EMP table. EMP table taken 97 milliseconds, but partition taken 84 milliseconds. If you run again non-partitioned one taken 94 milliseconds, partitioned one taken 11 seconds. So little difference, we see only little difference because it's small data. It is very small data. Let's observe how many records are there. How to find how many records presented in table? Count star, right? Select count star from EMP. Counting means calculation, right? So when calculation involves, reducer involves. Okay, just filtration, mapper involves. If there is any calculation, reducer involves. We already seen mapper and reducer, right? So in mapper, what we do, we just key value separation, right? We cannot perform any calculation. All calculations we written in reducer. Reducer. So count means it is going to count the number of records, right? So it is a calculation. Whenever calculation involves, internally reducer will generate. So total 10 records are there. So if data is huge volume, then we can see clear difference with partition and non-partition column. Okay. In this query, so I am creating multiple partitions based on gender and based on department number. Based on department number, I am creating partitions. Based on gender columns, I am creating partitions. So this partition is department number and gender. Department number and gender. So multi-column partition. Multi-column partitions. So we are getting query in this way. Select star from EMP where department number equal to some value x and gender equal to y. So we are getting these kind of queries. These kind of queries. So if you use this kind of query, then comparisons, how many comparisons? So assume employee records EMP table contain 1 lakh records. 1 lakh records, it will compare each record, each record, it will compare department number column with this value, gender column with this value. Means 1 lakh into 2, 2 lakh. So total 2 lakhs comparison. 2 lakh comparison. If you create the same thing in partition with this condition, with this approach. So department number and we are creating gender. Department number and gender. Assume we have 10 departments, 10 departments, then we are creating in this way. Each department, again we are creating subpartition is female. Let's observe table creation. Create a table, multi-column partition, list of columns and partition column names. Partition column names. Okay. So this time we are loading data using this select query only. Let's execute this one. So create a table partitioned row format delimited fields terminated by this is different colon, single quote is different. So describe m part table. These are columns. This is partition information. Partition table information. Okay, let's go metadata. Let's go MySQL. MySQL -u root -p Cloudera is a password. Use Metastore and select tbl underscore id comma tbl underscore name from tbls, right? So we just displayed only column name and partition. Let's describe DESC TBLS. So see the column names. We displayed only select TBL underscore ID comma TBL underscore name comma. Is there any table type? Yes. So TBL underscore type from TBLS. So we created table M part. M part is managed table type. Whether it is a partition or not, we are seeing where inside our Hive. Hive we are getting information whether this table is partitioned type or not. Whether this table is partition type or not. And if it is a partition type, and what are partition columns? What are partition columns? So next describe uh, E part, right? E part. Observe in E part column name we taken as gen. If you observe E part we taken as column name, partition column name is gen. But if you observe M part, column names, department number and gender. While creating partition column, we discussed we cannot use column name, right? A column name as partition column name. If you observe multi-partitions column, we taken in multi-partition column names, we taken column names, right? Multi-partition column, we taken column names. In multi-partition column, how internally it is going to create whether it may be multi-partition, whether it may be single partition column, internally it will create one directory, right? So how it forms this directory multi-column names? Multi-column names it forms like first let's observe single column. So emp e part, e part. So we have a column, gender column. So this is column, normal column and partition column. Partition column. This is column. This is column and partition column. Partition column if you take gender. So in a single table we cannot take same column name. That's why we renamed it as. So instead of this one we taken gen. But if you observe multi column M part, we have a columns department number, we have a column department number comma and gender. But partition column partition column partition partition column we taken department number comma gender. But finally it forms how it forms while creating under internally it is going to create like e part under e part it is going to create a gen equal to whether it may be female or male. This is the right side value. This is column name, right? But M part, we are using M part, it will create like this. M part, it will create a directory, department number, and gender. Gender. So this is not, this is complete partition column name. But this is not equivalent to this one, right? So that's why we taken same column names. So two columns form as a one column name condition. So this is not equivalent to any column presented in M part. That's why we can take. Okay. So next one, let's load data. So let's write insert query. Insert query to insert multiple values. So this is the query from EMP. Insert override table M part. So first here describe M part. M part we have only columns employee number, employee name, sal, department number and gender. So from EMP insert override table M part, partition columns, first partition column 11, gender equal to female, select we want columns of employee number, comma, e name, comma, sal and department number, comma, gender from EMP where department number equal to 11 and gender equal to female. Okay. Next, insert override department number equal to 11, gender equal to male. Select these list, department number 11, gender equal to male. So before this, let's open our M part. Currently there is no subdirectories, right? After execution of this statement, it is going to create multiple subdirectories. So insert override department number equal to 12 and female, and select these list, department number 12 and gender equal to female. And next one, insert override 12 male, right? Male, and select list and department number 12 male. Like this we write multiple conditions, then finally put semicolon. So how many partitions we are creating? 11 two partitions and 12 two partitions, means totally 4 partitions. Select the, oh yep, we did already mistake. Already from is there, right? So this is multi insert. This is optional. Any order we can select. It is not mandatory to select first female only. Still failure. Pardon? Condition rail. We have to write retrieving data, right? This is for partition column. This is for retrieving only in that partition. We want to store only this data. So here table inclusion 0 has 3 columns, but query has 5 columns. So table, let me see, yep, describe M part. So M part, employee number, name, sal, department number, gender. Let me see, I think while creation only we did table creation. M part table creation. Let's observe M part table creation. M part table creation, we taken only 3 columns. Department number and department gender we taken as condition columns. So retrieval we are using, yep, we taken only 3 columns. Gender and department number we taken as partition column names. So that's what I'm saying. We taken these 2 columns as partition columns. Only 3 columns. This is 11 and female. Only one insertion. I didn't say semicolon end. If you put semicolon, statement is ended. Yep. From EMP. So insert override. This one is we inserted female, right? Next one, select star from select details male, but remove this one and insert override. This one is 12. This time 12 and select department 12, gender equal to male. Insert override 12 female and select employee number Sal from department 12 female. Next semicolon. So in this way it will department number 11. Under department number 11 it is created gender. Under gender it is created files. So how it is creating structure? In multi-column it is creating M part. Under M part it is creating department number. Under department number it is creating gender. Gender equal to female and gender equal to male. So in this way it is creating partitions. So this time we get a file. So two comparisons, department level comparison and gender level comparisons. Within two comparisons you will get data. Earlier 2 lakhs comparisons. Now first level is department level. So department level. So 11 we have this data and 12 we have this data. 12 we have this data. So only two comparisons. Only within two comparisons you will get female and male data. Previously, after 2 lakhs comparison, you will get the data. So number of comparisons are reduced. Number of comparisons are reduced in multi condition. Let's refresh. So 11 it is created one, 12 it is created female and male. So let's write query. Select star from EMP where D number equal to 11 and gender equal to female. Let's write the same thing. M part, M part, M part. Department number equal to 11 and gender equal to F. Let's once again run previous one EMP. Once again run our M part. Once again run EMP. Once again run M part. EMP. M part. So we are getting without partition we are getting fast retrieval. With the partition we are getting slow, right? So this is small data. So this is directly coming from cache. So that's why we are getting faster response. But if data is huge, you will see difference. Only first time I think. First time. Every time we are executing same command, right? If there is any data side change, we get the difference. So data, there is no change at the data level. That's why we didn't see any difference here. So only one thing we have to observe is this is first, this is small data. We are executing these commands on small data. Even this data, observe what is the size of this data. Observe file size 48 bytes. Actually, let's take EMP file size. EMP file. This is EMP, right? Under EMP, if you observe complete files, so 121 bytes, 84 bytes. So two files are there. So 121 plus 84, 200 bytes. Total 200 bytes. So EMP file, complete EMP file, 200 bytes. Coming to our female, department number 11 and gender equal to female. This file size is 48 bytes. Yes sir. So 200 bytes is executed and 48 bytes executed. Sir, 48. So here it will just check condition, not with this one. Here in multi-partition level, it will check only condition, not file level. It will return complete file, right? Inside file, it will not compile anything. Only one thing comparison happen, this partition level. If it is matched, it will return whether file may be 48, file may be 1 KB, file may be 1 MB, 1 GB, 10 GB, 1 petabyte, anything. Simply it will return all the data presented from this one. But here it will compare entire data. If data size is small, we are getting very faster. If data size is huge, 1 KB or 1 MB, 1 MB or 1 GB or 1 TB or 1 petabyte, assume you will see clear separation difference. So 200 MB, 200 bytes, we are getting very faster. If it is 1 MB, you will see difference. If it is 1 TB, you will see clear difference. But here response time is same. There is no difference. Max seconds, little seconds wise difference. So max same seconds you will see here. Any number of times, if you execute M part, little seconds wise different, right? Seconds wise little different. Yes or no? So you may see maximum seconds, but if it is EMP table without a partition, based on the data size grows, definitely response time will increase. Because data growing means number of records are presented more. If number of records are more, conditions are increased. Number of comparisons are increased. If number of comparisons are increased, we will see change. Currently we have less data, that's why we are not seeing any difference. If data size is grown like this, you will see clear difference. But here data size may be any size. Only it will check only this condition. One comparison. In one comparison, you will get this data. Okay? So don't think here this is 48 bytes, this is 200 bytes, but difference is non-partition comes first. Okay? Based on the actual data, then you will see clear difference.